Today on Keen Academy, we'll be looking at CP45, number 7. Let's look at the question. A ball is projected from point A with an initial muzzle velocity v0, which is perpendicular to the incline shown. Knowing that the ball strikes the incline at point B, determine the range r in terms of v0 and beta. Consider the force of gravity acting on the projectile. Because the force of gravity is acting down on the projectile, the acceleration due to gravity is also down. Now, upon examining the diagram, you can see the acceleration due to gravity, which is equal to g equals 9.81 meters per second squared. This is because F net equals Fg, therefore ma equals mg, therefore a equals g. Also makes the angle beta with a line perpendicular to the incline. Now you can break AG or G into its x and y components with the incline as the x-axis to find the projectile's acceleration y and acceleration x. Acceleration y equals g cos beta. Acceleration x equals g sine beta. Next, you can tilt the diagram so the x-axis appears flat and treated like any other projectile motion question, albeit one with horizontal acceleration ax. Now apply your kinematics equation to horizontal velocity. R equals horizontal displacement, and g sine beta or ax is your horizontal acceleration. R equals v0 x times time plus 1 over 2 g sine beta times time to the 2. Note that since the projectile was fired at 90 degrees from the x-axis, there is no initial horizontal velocity, so the term v0 x times time is equal to 0. R equals 1 over 2 g sine beta times time to the 2. This is your first equation. Now apply your kinematics equation to the vertical velocity. dy equals vertical displacement, g cos beta or ay is your vertical acceleration, and v0 is your initial vertical velocity since v0 x is 0. You get d equals negative v0 t plus 1 over 2 g cos beta times time to the 2. Remember that v0 must be set as negative since g cos beta down is positive in our equation and v0 is in the opposite direction up. Note, because the projectile lands on the same level as its starting point on the x-axis, d equals 0. Therefore, 0 equals negative v0 times time plus 1 over 2 g cos beta times time to the 2. Now rearrange the equation. You can do this by factoring t out to get 0 equals t times bracket negative v0 plus 1 over 2 g cos beta times time bracket. And then you end up with v0 over 1 over 2 g cos beta equals time. This is your second equation. Because t, time at landing at point B, will be equal for both the vertical and horizontal motion, you can sub equation 1 into 2. R equals 1 over 2 g sine beta times 2 v0 over g cos beta to the 2. Simplify by applying the exponent 2 to everything inside the bracket. You end up with R equals 4 v0 to the power of 2g sine beta over 2g to the 2 cos to the 2 beta. Simplify further since g over g equals 1, so you can take out the g in the numerator and one of the g's in the denominator. This will give you 4 v0 to the 2 sine beta over 2g cos to the 2 beta. Simplify further by finding the lowest term for the coefficient 4 over 2, which is 2 over 1, and by applying the trig ratio sine beta over cos beta equals tan beta. This will give you r equals 2 v0 to the 2 tan beta over g cos beta. 7g equals 9.81. This will give you the equation r equals 2 v naught to the 2 tan beta over 9.81 cos beta. This is your final answer. Thank you for listening.